Welcome to RGES Algebra 1, Lesson 14B. We will be covering 610 and the Chapter 6 review. Now, in the oral practice, which I did not assign for you, but they were reminding you of this idea that we can figure out whether or not the solution to a quadratic formula will be composed of no real solutions, or we could have two types of real solutions, either real solutions that are rational, meaning they would either have a whole number answer like a 4, or something that terminates like a 4.13, or something that repeats like a 4.17 repeating. All of those would be considered rational. Or you could have a real value or two real values that are irrational. And irrational, recall, it means that it had a square root of something that when you plugged it in the calculator, and hopefully you're actually starting to recognize a lot of the ones that would be irrational, you might get an answer like 1781892, etc., and it has no repeating pattern involved in it. And so if we took something like the square root of a negative number, that would be no real solutions. And if we took something like the square root of 16, that would be a real solution that is rational. And if we took something like the square root of 37, that would be a real solution because it's positive, but it would be irrational. And you can always check that with the calculator. So that's the review there. And so then on 610, what they're saying is identify the nature, not solving, but just identify the nature of the solutions. Are they going to be rational? Are they going to be real? Are they going to be rational? Or are they going to be irrational if they are real? And otherwise, just identify the fact that they're not real. So you have three different choices. They're either number 1, not real, no real solutions. Number 2, they are real and they're rational. And number 3, they are real and they're irrational. And recall that the way we do that is we only solve part of the quadratic equation, the part under the radical sign, because of course that's what we're caring about here. And so recall the part under the radical is called the discriminant. It's found by b squared minus 4ac. And so if you had, for instance, negative 7x squared plus 2x minus 4 equals 0, you quickly pick up your b, that would be 49, minus 4 times a. Well, why did I pick up my a? I don't know. Let's try that again. You pick up your b. 2 squared is 4 minus 4 times a times c. Okay, my negatives, I'm going to be subtracting a much larger number than 4, so this is going to be no real solutions. And that's as simple as you do it, and you can really be doing this kind of calculation almost in your head, sometimes in your head. Now, when we get down to problems 21 through 33, all you have to do is recognize that there will be some manipulation you have to do in order to get it in the proper form so that you can go ahead and solve for the discriminant. Okay, and remember, even though I'm saying solve, I'm really only evaluating it to decide is it going to be negative or positive, and then I guess you really do need to solve the discriminant part to decide if it's rational or irrational. Okay, so for 22, one that was not assigned, let's look at this real quickly, just a couple of these to remind you. I would, 10, I would have to, of course, take this to the left-hand side because I need this equation set to 0 before I can use the quadratic formula. If you have 24, x squared minus 2x minus 8 equals 3x. Again, I would simply move that to the left-hand side to set it to 0. And so you've got, sometimes you might have to reorder the terms, that kind of thing. They're not terribly tricky, but they're just alerting you to the fact that you will need to do some manipulation before you just go ahead and plug in values. Now, for these last problems, these word problems, of which I asked you to do the odd ones, and I'm going to walk through the first one with you. Recall this formula represents the vertical distance that an object travels, and for each second t, okay? Where r represents the initial velocity or the initial rate, this would represent the distance, and the t would represent the number of seconds since it's been thrown up. And recall that the trajectory would be an upward motion to a certain point, and then because of gravity, it would be pulled back down again at this much faster rate. Notice with a t squared velocity, and this would be a constant. It doesn't change. Now, if you have a problem that says something like this, the anti-aircraft problem, a target plane flies at 2,100 meters, an anti-aircraft gun fires a projectile with an initial upward velocity of 200 meters per second. Will the projectile ever reach the altitude of the target plane? And you have to justify your answer, okay? So here you've got a plane flying up above at 2,100 meters, and you're going to try to shoot a bullet, right? And will it ever get that high? Or will it start falling down before it gets that high? That's the question, okay? So this would be my distance. I would plug that in. Okay. The rate I know is 200 meters per second. I don't know the time. The time could almost be anything. I'm wondering, is there at any time will there be a solution to that where it will hit that amount? Okay. So we'll leave that at t, and we'll leave that at t squared. Go ahead and take everything to the left-hand side of the equation, and we would get 5t squared minus 200t minus 2,100 equals 0. And I'm asking, is there a solution? Is there a solution if it equals 2,100? Okay. For when it equals 2,100, a real solution. And so what do I need to do? Use the discriminant. 5 squared, b squared would be 200 squared. The negative, of course, negative times the negative would be a positive, minus 4 times a times c. Sorry, I had a little bit of a sign problem there. 200 square would be 40,000. Minus 20 times 2,100 would be 42,000. And of course, that's going to give me a negative number. And the answer is there a real solution? Is there any time where that anti-aircraft gun would be able to fire a projectile that would hit that plane if it's flying that high? And the answer is no. And that's the kind of way that you would use this in an application world. So you go ahead and give the other two a try. Then let me look at anything I might want to warn you about with the chapter test or the chapter review. Okay, looking at the chapter test problems, beginning with 263, you were assigned starting with number 3. So I'd like to look at page 263, number 1 and 2. And just discuss these with you. If you recall, what's the difference in each case? The square root of a negative number, in this case negative 36, is irrational. I'm sorry, It's imaginary. It's not real. And the absolute value of a negative number is its positive counterpart. Remember, this is distance from 0 on the number line. So this would be 36, right? Radical and radicand. The radical is the operation. This is the operation, the radical. Like addition or subtraction or multiplication. This is my operation. And the radicand is what's under the radical. So the 36 would be the radicand. The quadratic equation and the quadratic formula. A quadratic equation is simply an equation that has the highest term as a square. Okay, that would be what we call the quadratic equation. The highest value of the term would be a square. The quadratic formula is that one you've memorized. X equals negative b plus or minus square root of b squared minus 4ac all over 4a. We have two formulas here. We have d equals rt. This is for constant rate, the distance at a constant rate, like he's traveling at a rate of 40 miles per hour for 5 hours. What would his distance be? Whereas this represents the distance traveled when something is thrown up. So this is a vertical distance because it takes into account the arc up and down because of the force of gravity, okay, with this maximum here. All right. The quadratic equation with a positive discriminant, you've done a lot of practice just now on that, and one with a negative discriminant. So I won't repeat that. See, that's what the whole section 610 was about. If we're looking now at number 2, write each of the following, the quadratic formula, we just did that. A radical that's irrational. A rational number, let's see, I want to take some radical here of something that would end up being rational. How about that? And that would end up being a whole number, and a whole number's certainly rational. I could have even done something like this, because that ends up being 3/2, and that's also rational. That's also rational. What does the square root of n squared equal? Now recall this is a definition that's important. Okay, so that equals the absolute value of n. So make sure you understand that. And then we turn it into what? That equals plus or minus n, because that's how we deal with the absolute value. But this part is a very important idea you need to remember. Learn it if you haven't. The coefficient in the expression x squared, let me just go to the next page. The coefficient to x squared would be the 1. The coefficient is, or the numerical coefficient, I'm assuming that's what they mean, is 1. If I'd had a negative 3x squared, the negative, or the numerical coefficient would be negative 3. The number to add to x squared plus 7x to complete the square, that's a good review. If we have x squared plus 7x and we want to complete the square, we recall we would take half of this, go ahead and use fractions, and then we would square it, and that's what we would have to add. And I think fractions are just ideal for this kind of question. Okay? The rest you're asked to do on your own, and come back to class with anything you feel that you're struggling with at all or have any questions, because not all of them will have answers. I probably won't go ahead and have the answers go over every answer together. I'll have you check your answers with one another and go over things that you find at all confusing. But please be diligent, because this will serve as your review before the test.